So we have angle alpha in here, and then the particle projected up the plane with velocity u at an angle theta to the plane. So we're talking about this angle here, and that's going to be angle theta. Okay, then it comes up and hits it. The plane of projection is vertical and contains the line of greatest slope. Prove that the particle will strike the plane horizontally if tan theta equals sine A cos A over 2 minus cos squared A. Okay, so if it's striking horizontally, it means that the landing angle is also alpha. So therefore tan alpha equals minus phi y over phi x at time of flight. So what I'm going to go through first is creating my 4 equations. Okay, so let's do that really quickly. So we're going to have gravity. So gravity, so we're going to, that's going to be alpha. So you're going to have a g cos alpha and g sine alpha. And then we're going to break up this u value. So we're going to break up u as the hypotenuse, and that makes it u cos theta, u sine theta. U cos theta along this direction, u sine theta along this direction here. And now we're going to set up our equations. Okay, so we'll do it over here. Okay, so phi x, guys, is going to be u cos theta. U cos theta plus AT minus GT sine alpha. Phi y is going to be u sine theta minus GT cos alpha. Sx, add on a t, ut cos theta minus a half GT squared sine alpha, and then Sy equals ut sine theta minus a half GT squared cos alpha. What we have next, guys, is we got to find our time of flight. So we got to find out how long it takes to hit the plane. So we're going to put Sy equals 0, which is basically this equation here equals 0. So it's going to be ut sine theta minus a half GT squared cos alpha equals 0. What I can do there is I can just turn that into the equal sign and get rid of that. Now, cross off a t. It's going to be this t here and this t here. And then we're going to have 2u sine theta over g cos alpha equals t. Alright, so 2u sine theta over g cos alpha equals t. Now that we've done that, we're going to have to find phi x and phi y. So it's just a matter of putting into the phi x formula and the phi y formula. So phi x is going to be u cos theta minus gt, so it's going to be g times 2u sine theta over g cos alpha multiplied by sine alpha. Then the next one's going to be phi y, which is going to be u sine theta minus g times t 2u sine theta over g cos alpha, all multiplied by another cos alpha. That will in turn be equal to u cos alpha, or u cos theta, sine alpha over cos alpha, tan alpha. So minus 2u tan alpha. And then the other one will be the cos alphas cancel, the g's cancel. That's going to be u sine theta minus 2u sine theta, which is just minus u sine theta. Lads, don't forget the sine theta, still here from back here, and it was the sine alpha over cos alpha that gave us the tan alpha. Okay. Full point of the question is to turn tan theta into sine alpha cos alpha minus 2 cos squared alpha. So what I'm going to do next is I'm going to say the tan of the angle of the plane being alpha. Tan alpha is equal to minus Vy over Vx. And what that's going to get me is u sine theta divided by u cos theta minus 2 u tan alpha sine theta. Now it's going to be all about isolating tan theta. Okay, so we're really going to try hard to do that. Now that's going to be tan alpha here. Now I'm sort of looking at getting rid of the u's at the start. They can all cancel. The next thing we're going to do is cross multiply, so we're going to get tan alpha cos theta. I'm then going to get so does everybody understand that I'm multiplying this part here by everything down here? Okay, the next part, lads, is going to be what? 2 tan squared alpha sine theta. Once again, multiplying the tan alpha over here by this here, because this is all coming up, that's going to equal sine theta. Now, to pick up more marks, what's a quick way of turning sine theta into tan theta? Sorry?
Cos over sine.
Sine over cos. There's no convenient cos's at the moment, is there, to cross multiply underneath? So let's force it. Why don't we just divide everything by cos theta? Force tan theta out of this equation. At least you're starting to look a bit more proper. Tan theta, once again, bring down the object of the question. Okay. Now, let's see what happened to us here. Well, we're going to have that cancels. Yeah. Sine theta over cos theta on the other side. Anybody? Huh? Tan theta. Going to do next is I'm going to bring all of this over to your side. I'm still not panicking. It's just all about getting tan theta on its own. I haven't got a clue where I'm going at the moment. That's the honest truth. All I know is the logical step is to have one tan theta. Okay. So tan theta. I think I'm starting to see it. Now, tan theta plus 2 tan squared alpha tan theta. Can anybody tell me my next step now? How many tan thetas are in my end equation? Which is this thing here. How many tan thetas do I have? 1. So I need to factorize it. By factorizing, you turn 2 into 1. Now, it's going to be interesting. So, what I'm going to have next is tan theta equals tan alpha over 1 plus 2 tan squared alpha. Now,
What's this tan?
sorry?
You didn't factor it into tan squared.
This one here?
Yeah, can you factor it?
I only took out tan theta, this one and this one. So still there, okay? Now, looking at this, it looks nothing like what I have over here for the time being. So, everywhere I have tan, I'm going to have to turn it into sine alpha, cos alpha, and see what I can make out of it. Okay? So it's going to be sine alpha over cos alpha. And then on the bottom we're going to have, what's that going to be? That's going to be 2 sine squared alpha over cos squared alpha. The other side, I'm going to change the number 1 into what? What would be a good thing to change the number 1 into? Yeah, I can go one better on that. Cos squared alpha over cos squared alpha. What's the advantage of doing that?
Same.
Sorry?
Same bottom line.
Same bottom line. Okay. So what we're going to have here is tan theta, and it should be sine alpha over cos alpha. Oh, sorry, we're not doing it that way again. So, anybody suggest what I could break up the 2 sine squared alpha into? See the 2 sine squared alpha? What I'm going to do with that is I'm going to change it into sine squared alpha plus sine squared alpha. Anybody? Is that alright? 2 sine squared alpha is sine squared alpha plus sine squared alpha. Now what's cos squared alpha plus sine squared alpha? 1. You develop a feel for these after a while. For the time being, it's really confusing. Over. Now, finally, bring the fraction to the top and turn it upside down. So we're going to have sine alpha multiplied by cos squared alpha, all divided by cos alpha times 1 plus sine squared alpha. So what's going to happen this time? Where did my 2 go? Sorry, 1 second. See if I can. Okay, we're nearly there. Nearly. Okay, so this cos alpha changes with that one there. So we're left with sine alpha over cos alpha. Okay. Now the bottom is 1 plus sine squared alpha, which doesn't look anything like this here. Okay. So we're going to have to see what we can do about the bottom. We're very close. Okay. So I'm trying to think. And we got it. Anybody know what to do with the sine squared alpha? Thank you, Neil. And then so you're going to change that to 1 minus cos squared alpha, and long behold, sine alpha cos alpha all over 2 minus cos squared alpha. And that's what I was asked to prove, right?